Ready? What's up, guys? It's Friday. How are we feeling? Good. Good, good, good. So here's the deal. Today we're talking about trig functions and specifically reciprocal trig functions. What's that word mean, reciprocal? Be careful of the words that you want to use. You want to say the word flip, right? The reciprocal of 2 over 1 is what? Good. So here's the deal. Reciprocal trig functions are, here are the normal ones, sine, cos, and tan. And then we got the reciprocals, and they have some funny names. Cosecant, secant, cotangent. All they are, the reciprocal of sine is cosecant, and since sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. That's it. That's all we're doing today. Reciprocals, flip, okay? But here's what you need to know. You literally have to have this memorized as almost a reflex action. In other words, I say the word, what's the reciprocal of sine? You don't even think. It should just say, you should just be like, cosecant. Like, damn, how'd I know that? You know what I mean? What's the reciprocal of cosine? Secant. It's almost like you'll have Tourette's, like you'll just yell out. You know what I mean? Okay? All right? You can't control yourself like that. Okay? That's what I want it to be like. All right? I don't want you to think. I want it to be natural. And however you manage to do that, that's what it takes to be successful at for this topic. Right? You have to memorize it. There's no other way. Okay? So spend time. Make up cue cards if you have to do it. Make up some kind of mnemonic device. Like for me, how I remember it, no two cos go together. You know what I mean? Sine and cosecant. There's no two cos. Cosine and secant. Because the natural tendency for people is to think that cosecant goes with cosine. No. No, no, no. Tangent, cotangent. No two cos go together. That helps me memorize this list. Guys, we got that down? There's one other thing that I'll need you to memorize, and that's this. Not only are the cosecant, secant, and cotangent the reciprocal of sine, cos, and tan in terms of their sides, they're also the reciprocal of them in terms of the functions themselves. In other words, cosecant, because it's the reciprocal of sine, can also be rewritten as 1 divided by the sine of theta. And that's going to help you when you have to try and think about how you can plug this into your calculator. Your calculator does not have a secant, cosecant, or cotangent button. But you can use this idea when you want to use your calculator to answer questions that involve these functions. And we'll get to them later on. Don't worry about it. But just know, this also has to be on command. Secant theta, immediately, 1 divided by the cosine of theta. Okay, so here we go. Now people have been asking, so like, how do we use this? Here's the information in action. We're going to attempt to solve this problem. A and B. First, we're going to find the length of the third side. And then we're going to find the value of the 6 trig functions. The 6 trig functions being sine, cos, and tan, cosecant, secant, cotan. Whoa. So let me give you a minute to just write the problem down, think about it, and then we'll talk about how we're going to solve it. Okay. You ready? Let's do this. Let's do this. So it's a right triangle. How do you figure that last side? That's a trick. Courtney has figured out a trick. Courtney, we're going to come back to you in 2 seconds, right? Courtney, do you know what this last side is without doing any work? Good. Hold on. Hold on. I know you guys are thinking, like, how did she do that? We're going to see. Ready? So, if it's a right triangle, we can use a very famous theorem. Sorry about that. Pythagorean Theorem. Pythagorean Theorem is a squared plus b squared equals c squared. What goes in the spot for C? X, Y. What? Because it's the hypotenuse. The hypotenuse always goes in this C spot. Nothing else. It doesn't matter where the other two sides go for A and B, but in that C spot, it's always the hypotenuse. Okay, let's do this. Let's do this. So we're going to do 8 squared plus 6 squared equals x squared. 64 plus 36 equals x squared. 100 equals x squared. That means x has got to be 10. Whoops. It's a Pythagorean triple. Hill, tell us, what is a Pythagorean triple? There are all these really famous right triangles, and we call them Pythagorean triples. And one of them is a 3, 4, 5, as Dominique has suggested, right? Dominique, she's saying that it's a 3, 4, 5 degree, it's a 3, 4, 5 triangle. It's just what? It's twice as big. So she saw the 3 in the 6, the 4 in the 8. And if both of these are just twice as big, without doing any work, Hill, you know that the last side had to be 10. That's a cheap shortcut. Yeah, it is really awesome. So now let's do B. Let's do B, right? Let's find the value of all the trig functions. Oh yeah, let's start with sine. Whoops. You know what? I don't want to do it there. I'm a neat freak. Let's do B. So what's the sine of angle theta? 6 over 10, because it's the opposite side over the hypotenuse. How about the cosine of theta? How much is that one?
8 over 10.
It'd be 8 over 10. Do you want me to label up the triangle for you? Okay. If we're to label up the triangle, take a look. There's angle theta. This is going to be the opposite side, right? This is going to be the adjacent side. And this is the hypotenuse. So that's how we're going about filling this out, right? Opposite over hypotenuse. Adjacent over hypotenuse. Geez, man, you okay? All right. And finally, the tan of theta. Okay, 6 over 8. Oh yeah, oh yeah. Now, let's play. What's the reciprocal of sine? Nope, what's its name? Cosecant. No two cos go together, right? Cosecant of theta is just 10 over 6. You just flip it. The reciprocal of cosine is what? Secant. No two cos go together. Secant is just 10 over 8. You know, tangent's like the easy one, right? Cotangent. Cotangent is just 8 over 6. That's it. That's all you had to do. Is this hard? Nope. Here we go. Now on your own, please, A, find the missing side. B, find the 6 other trig functions. So I'm going to do the first part with you together as you're working on the rest. How do you find that missing side, Sophia? You're amazing, girl. Pythagorean Theorem. All right, so that's how you do it using Pythagorean Theorem. Fill it out. Be very careful where you're plugging in for x. Remember, in that C spot is always the hypotenuse. Okay, so this is now 5. Now we're going to go about trying to find the 6 other trig functions. So here you go. Here's the answer. Those are the 6 trig functions that I'm looking for. Let's go big screen for a minute to take a look at what it should look like, and there you go. It's the same process over and over again. Damn, look how beautiful those notes are. That's nice. Not necessarily new, but we're just going to try and attack it from a different perspective. Same idea. Now I'm not giving you the triangle. I'm giving you one of the ratios. And I want to see if you know you can be creative to try and figure out how you could find the other 5. Don't yell out. Just take the problem down, think about it, and then we'll take some suggestions in a minute. Guys, we got some great suggestions. Great suggestions. Now this is going to be the theme. This is going to be the theme of this class for trigonometry. Given the least amount of information, can you figure out all the stuff? Right? Think about it to yourself. What is this top number? It's the opposite side. And what is this bottom number? It's the hypotenuse. So if you know that, guess what you can draw? What's up? Doesn't make a difference which angle it is. Everybody's triangles will be different, but we all should get the same answer, right? Which one do you want it to be? Do you want it to be this one up over here on the top or with this one on the bottom? Okay, I'm down with that. There's angle theta, and so the side opposite angle theta, let me do it, is 15. The hypotenuse is 17, and now it's just like the other problems. This one down over here is going to be x for the time being, and I'm going to use Pythagorean theorem, right? You never worried about what? Don't worry, it's supposed to. This is all about ideas. 225, 17 squared, I think it's like 169. No, 280. 289. 289, subtract 225 over. How much is x squared? And then x has to be 8. Nice. So now we got our last side. We got our last side. Let's find out. Now let's label it up. I always have to do this because I get all messed up. So this is, I got to remember, is the opposite side. This is the hypotenuse. This is the adjacent. That's going to help me with my trig ratios, right? Because there's my triangle. Let me get a good color. I don't have red being used yet, right? Let's do the sine. Sine of theta. What's the cosine? What's the tan? Nice. Nice. Now I don't even need my triangle because if I got those, what's the reciprocal of sine? Very nice. Cosecant of theta. 17 over 15. Very nice. The reciprocal of cosecant of cosine is secant. That's it. That's all you had to do. Let's take a look at our work. Let's see how it matches up. Perfect. You like this? Good. So here's your classwork. Let's do this on your own. If you need some help, I'll come help you. Good luck. Let me give you a little bit of a hint. A little bit of a hint, right? Okay. Suppose that you wanted to, first of all, how are you going about trying to attack A? Did you use your calculator or did you do it by hand? For those people that decided to use your calculator, let me help you out. Look, obviously, you have to use the Pythagorean Theorem. And hopefully you wrote it down, right? Some people are choosing to go the route of like putting down decimals and stuff, right? Be very careful with that. Especially with rounding, you will tend, if you start rounding early on, to get random answers. Plug it in. This is going to be 4 squared. Whoops. You know what? Let me go back to the big screen because the computer has a really slow time trying to plug it in like that. So it's going to be what? 4 squared plus what? Plus x squared equals, how much was the hypotenuse worth? 4 radical 2 squared. And let me show you something so that we're recording. Where's my calculator? If you're trying to plug 4 radical 2 squared into your calculator, you have to put a parenthesis around it. Because it's got to be 4 radical 2 being squared. If you put that squared symbol, if you use the squared symbol without the parentheses, let me show you what you'll get. So 4 radical 2 squared is 32. Watch what happens for some other people that entered into your calculators. What's it squaring? It squared the radical 2. So don't do that. You got to put it all in parentheses. Okay? 16 plus x squared equals 32. X squared equals how much? And so x is how much? Good. So there you go. That's how much x is over here. Right? Yeah. Lou, what's up, buddy? What's up? Okay, I'll be there in 1 minute. Let me divide everything. Hold on 1 second. Let me just finish this one up right here. Did everybody get 4 for that other side? Good. Now let's just do the second part. Find the other trig functions. No, I'm not, sorry. We got to do the second part of part 1. I should have labeled this. This is 1A. Now let's do 1B. Whoops. 1B. So this one's 4, right? So how much is the sine of theta? Sine of theta is just going to be 4 over 4 rad 2. No, because that's 32 is what happens when you squared it. Right? Uh-oh. Uh-oh. What's uh-oh? What's uh-oh? You know, maybe we'll hold back for today. Maybe we'll hold back from today from trying to do all the math because we're going to run out of time. But if I asked you to simplify that, think to yourself, what's wrong with it right now? The bottom part can't be a radical. But we'll go through that afterwards. For the time being, for right now, leave it like this, okay? The cosine of theta, how much is it? How much is the tan of theta? Yep. How much is the secant, the cosecant? It's 4 rad 2 over 4. How about the secant? And how about the tan, the cotangent? Sure. You know, I'm not worried so much about reducing for the time being for right now. I just want you to get the hang of it. Did everybody manage to get the hang of it? Good, 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 good.